In today's lecture, I will tell you 5 simple steps with the help of which you can draw the Lewis structures. The first step is count all the valence electrons. I have told you in the previous video that element present in a particular group will have the same number of electrons in its valence shell as its group number. Have a look, it means that elements present in group 1 are having only one electron in their valence shell, like hydrogen, lithium, sodium, they all will be having only one valence electron. And similar goes for 2, 3 and 4. 2 will have 2 valence electrons, 3 will have 3 valence electrons, 4 will have 4 valence electrons. Now let us take the example of CO2. Now from here and from the periodic table in front of you, you will get to know that carbon is present in group 4. We can see here that we have one carbon and 2 oxygens, right? So we will write the valence electron of carbon, and how many carbons are present? Only 1. So we will multiply 4 with 1. We will get the answer 4. Oxygen, we know that it is present in group 6 of the periodic table. So 6, and how many oxygens are present? 2. So we will multiply both, we will get 4 and 12. We will add these answers. Now 12 plus 4 is equal to 16. So how many electrons total we have? We are having 16 electrons. Now step 2 is determine the central atom. The one which will be present alone will be considered as central atom. So which one is alone? Carbon. There is only one carbon present and 2 oxygens. So we will consider carbon as central atom in this case. Now step 3 tells us draw single bonds to the central atom. We have one carbon, 2 oxygens. Now we will draw single bonds, right? One bond with this carbon oxygen and one bond here. Remember one thing, that one bond represents 2 electrons. One bond is equal to 2 electrons. Now how many electrons we have used in this bonding? 2 electrons here and 2 electrons here. So total we have used 4 electrons. So from the total electrons, which we have 16 electrons, we will minus the 4 electrons that we used over here in the bonding, right? When we will subtract this 4 from 16, we will get 12. Now how many electrons are left? Only 12 electrons. Now let's see what this step 4 tells us. Now step 4 tells us that put all the remaining electrons on atoms as lone pairs. How many electrons we are left with? 12 electrons. Let's see over here. Here we will put the valence electrons in this way. Let's count the valence electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. How many we were left with? Only 12 electrons. Put the remaining electrons on the atoms. Now according to step 5, turn lone pairs into double or triple bond to give every atom an octet or duplet. We have studied the concept of octet and duplet. Each oxygen and carbon should have 8 electrons. Oxygen is having how many electrons? 1, 2, 3, 4, 5, 6, 7, 8. Similar goes for this oxygen. It is having 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. Each bond is representing 2 electrons. Now let's see if carbon has 8 electrons or not. How many electrons it is having? 1, 2, 3, 4. Each bond is considered as 2 electrons. 2 plus 2, only 4 electrons. So carbon is having 4 electrons. How many electrons we need for carbon? We need 4 more electrons. What we will do over here, that according to step 5, turn lone pairs into double or triple bond to give every atom an octet or duplet. Now what we will do, that we will remove these lone pairs from this oxygen and we will turn it into a double bond, and we will remove these lone pairs from this oxygen and we will turn this into double bond. It is also having 8 electrons. Now, if you understood this example, it will be easy for you to understand and solve all kind of examples. And if you have not understood, restart the video and watch again from the start. Once you understood this example, then watch the remaining video. Now, the next example that I am going to discuss with you is of HCl. Now, let's start. The step 1 was count valence electrons. We have H. We know it is present in group 1 of the periodic table, so it is having only one valence electron, and there is only one hydrogen present, so we will multiply it with 1. Now we know that chlorine is present in group 7 of the periodic table and only one chlorine is present, so we will multiply it 1. After multiplying them, we will get an answer of 1 and 7. We will add them and we will get an answer 8. So it means we are having total 8 valence electrons. The second step was to determine the central atom. Here we are having only one hydrogen and only one chlorine, so there is no need of doing the step 2. So we will go towards the step 3, which was draw single bond. So we draw a single bond between hydrogen and chlorine. The step 4 was put the remaining electrons as lone pairs. Now let's see how many electrons we are left with. We know that one bond is equal to 2 electrons. So from 8 we have used 2 electrons. So after subtracting 2 from 8, we get an answer 6. It means that we are left with 6 valence electrons. The step 4 tells us put remaining electrons as lone pairs. So now we will put these electrons on chlorine. But why we will put on chlorine? Why not hydrogen? Because we know that hydrogen needs only 2 electrons to complete its valence shell, and it is already having these 2 electrons. Now, what about chlorine? We will put the remaining 6 valence electrons on this chlorine as lone pairs. So now this is the Lewis structure for HCl. Now let's go towards the other example, that is NH3. So step 1 was count the valence electrons. We know that nitrogen is present in group 5 of the periodic table and only one nitrogen is present, so 5 multiplied by 1 is equal to 5. And hydrogen is present in group 1 of the periodic table and only 3 hydrogens are present. When we will multiply these, we will get an answer 5 and 3. Now we will add these, we will get 8. Now the step 2 is determine the central atom. Now which one is present alone? Nitrogen is present alone, so we will consider it as the central atom. So nitrogen will be the central atom in this case. Now the step 3 was draw single bonds. Put nitrogen and 3 hydrogens and draw the single bonds. We know that each bond is representing 2 electrons. So how many electrons we have used here? We have used 2 plus 2 plus 2. We have used 6 electrons. It means that we are left with only 2 electrons. The step 4 tell us put the remaining electrons as lone pair. Now we have 2 electrons left. Where should we put these 2 electrons? On this hydrogen, or this hydrogen? We will not put these lone pairs on hydrogen. Why? Because I already told over here that hydrogen only needs 2 electrons to complete its valence shell. It is already having these 2 electrons. Similar goes for this case. This hydrogen is having 2 electrons. This is also having 2 electrons. This hydrogen is also having 2 electrons. Now let's see the nitrogen. Nitrogen should have 8 electrons. And how many electrons it is having? 2 plus 2 plus 2, 6 electrons. It is having 6 electrons. So it needs how many more electrons? It needs 2 more electrons. So we will put these 2 electrons as lone pairs on this nitrogen. This is the Lewis structure for NH3. Now with the help of these simple steps, you can draw the Lewis diagram for any molecule or compound. At the end, I would like to tell you that there are many exceptional cases as well. And if you want me to explain other examples, then let me know in the comments below. If you understood the topic, then don't forget to like, comment, share and subscribe my channel.